Right, so our next question in the playlist, this is question 6 of AQA GCSE Chemistry Higher Tier Paper 2. So I'm going to talk through the questions, some strategies, some comments from the examiner's report too. Now, I'm going to put a link again in the description just in case you want to print off the specification for revision and the question paper to fill in as well. Right, so this is an extended response question for 6 marks. So remember, we're not looking for 6 individual marking points. We are looking for a judgment that is strongly linked and logically supported by a sufficient range of correct reasons to score 6 marks. So we're evaluating the use of aluminium and bamboo for making bicycle frames and their use. So with evaluation, we're looking at strengths and weaknesses. How could we link ideas together? Well, one good strategy when you've got numerical data, such as in this table, would be to do a calculation comparing the two materials. So as an example of the type of calculation that you could do one that compares the cost per year based on the minimum lifespan to back why, say, aluminium alloy is a better choice. Now you can choose either material as the best overall, so long as you provide correct reasons to back your answer. So if you use my example and you compare the cost for each one based on the minimum lifespan, the cost for the aluminium alloy, it says the frame is £250. If it only lasts for 6 years, then that's a cost of £41.60 per year, whereas the bamboo would be £150 per year, so more expensive. So you could then link that to another reason and say therefore the aluminium alloy could be replaced more cheaply after a few years, something like that. So remember, it doesn't have to be an essay, you're just linking ideas together, you don't have to cover absolutely everything, but here are some examples of what you could say. So bamboo is renewable, so you could say, it can be replaced, it can be grown back, whereas aluminium is a finite resource, there's a limited amount of aluminium ores that can be obtained. Growing bamboo uses up agricultural land, which is therefore not being used to produce food, but mining aluminium ore is a polluting activity, so that's a negative. We've talked about cost. Aluminium alloy is stronger, so it can withstand larger forces, or you could say bigger people. Aluminium alloy has a lower mass. So the bicycle is faster, easier to carry, transport. The aluminium alloy frame doesn't last as long, so it needs to be replaced more frequently. The aluminium alloy is recyclable, so aluminium ores are conserved, but bamboo can be used to produce renewable heat energy. So this means that the bamboo compared with the aluminium contributes less to global warming, or you could say as well it's carbon neutral. Now, while you do have to justify which one you think is the best material, because we are evaluating, in terms of the end of their life cycles, both of them have a sustainable disposal method, so there's no reason why either of them should reach landfill. So there's quite a lot of useful information in the examiner's report for this question. So it says most students were able to compare the given data with mathematical processing commonly seen, and this is where the majority of the credit for linked reasons was awarded. And they also say that most of the linked reasons shown in the mark scheme that I read out were rarely seen. Also, many students thought that burning bamboo to produce heat energy as a method of disposal was a negative point. and commonly referring to the release of carbon dioxide as problematic. Well, that's wrong, because the heat energy released could be used to make electricity, and there's also the fact that because the bamboo can be grown and harvested, used for the bike and then burnt afterwards, and more bamboo grown means that overall its use is carbon neutral. So the CO2 taken in by the bamboo when it's growing for photosynthesis is the same as the carbon dioxide that's released when it's burned. Okay, it's not as simple as that, because you've got processing, you've got transportation, but compared with using an aluminium alloy, it is more favourable in terms of reducing contributions to global warming. Right, so one of the key takeaways here then is to understand what particular command words mean in exams. So in this case, the word evaluate. So you are comparing the two materials, advantages, disadvantages. It's important that you do that and that you come up with an overall answer. Now, around 1/5 of students gained a level 3, with roughly a further 55% achieving a level 2. Right, so the next question is about corrosion and its prevention. So if you want to do some revision, that's on page 85 of the specification. So the question is, why does aluminium alloy not need protection from corrosion? Right, so the first mark is for saying that aluminium, or the aluminium alloy, has an oxide coating, which of course would be on its surface. And the second reason, so this therefore prevents contact between aluminium, or the aluminium alloy, and either something that's going to cause corrosion, so water, you could say air, or the oxygen that's in the air. So looking at the examiner's report, the first mark was scored quite often, but the second mark, where there's some idea of contact between aluminium and something else needed for corrosion to happen, but is being prevented by that oxide coating, was rarely seen. So less than 5% of students actually scored both marks, and there were several misconceptions. One of them being that aluminium has too low a reactivity to react with water or oxygen, which of course is not true. It has quite high reactivity. Also, there was the mention that other metals present in the alloy prevented the aluminium from reacting with water or oxygen. So in other words, there was some idea of sacrificial protection, which is not correct. And some students thought that iron was the only metal that could corrode. Right, so the next question is about the bicycle chains. You're told they're made from an alloy of iron, in other words, a mixture of metals, and that bicycle chains will rust without protection. You were told that paint is not used to protect the bicycle chains from rusting, so you need to suggest, which means come up with any sensible answer, how a bicycle chain can be protected from rusting. So this question was well answered, with around 3/4 of students gaining this mark. So there was a better understanding when it came to bicycle chains and protection than compared with the previous question. So you've got the barrier method, so you're preventing oxygen or water reacting with the iron. So you could coat with grease or oil, you could galvanise, or you could use stainless steel instead as the alloy. So 6.4 is a question about a composite material. So for revision, you might want to look at page 87 of the specification. So in composites, according to AQA, fibres or fragments are known as reinforcement, and they are surrounded by a matrix or binder, in this case the polymer resin. Right, so looking at the examiner's report then, it says that only 15% of students were awarded both marks. Right, so I'm looking at this. It might be because they have said in the question what description, which can be interpreted differently by students, I would say. So instead of saying the name of the various part of the composite, as mentioned in the specification, students described properties instead. So a lot of students said strong or flexible or light. Right, that's the end of that question, but the others are in the playlist. So if you subscribe, you'll be notified when the other questions become available, as I haven't produced all of the videos yet. I will also produce videos for some other exam papers as well.